We want to go over homework 1.8. Question number 1. We have to find the domain in interval notation. Since we have a rational function, so we call this rational function, as you see, is a fraction, and you have a polynomial in the denominator and a polynomial in the numerator. So we call this function, which is a fraction, a rational function. And the idea of domain is, what are the x's that we can pick for the function? What am I allowed to pick for x? Because remember, this is your input, and your input goes from negative infinity to positive infinity, all the real numbers. Am I allowed to pick everything? Can I put all these numbers for x? That's the idea of the domain. If you have a rational function, you have to make sure the denominator does not become 0. If it does, then you have to say that I can pick any number, but that number or the numbers that make the denominator equal to 0. So the sea of numbers from negative infinity to positive infinity are, like, for instance, some of them are -1, -2, -3, 1, 2, 3, 5, 10,000. All these numbers are here. Am I allowed to pick any of them I want? The only thing we cannot pick in this case is -3. That's forbidden. Everything else is okay to pick. How did I find that? The way you find it, you say, let me set the denominator, x plus 3, equal to 0, and find out what x is going to turn x plus 3 equal to 0. So you subtract 3 from both sides, positive, negative, cancel each other. 0 plus or minus any number is 0, is that number. So we get x is -3. That's the only bad point. That's the only number I cannot pick for x. So therefore, the domain is, if this is my real number from negative infinity to positive infinity, let's say 0, 1, -1, -2, -3, everything is fine. I can pick any of these numbers and any of these numbers. The only thing I cannot pick for x is -3. How do we show it in interval notation? You start from left. For infinity and negative infinity, you always put parentheses, comma. We don't want -3. Since we don't want it, we don't put bracket, we put parentheses. Again, from -3, I can pick everything to positive infinity. Remember, for -3, we are putting parentheses to exclude -3. For infinity and negative infinity, we put parentheses. So next question says, write the domain in interval notation. We do have a function. It's called the square root function. We don't want to have negative under the radical, otherwise this is undefined. So we say a plus 7 must be greater than 0. What a's will make this greater than 0? The question is it okay for a plus 7 to be 0? Yes. So we want to solve this inequality and find out those a's that make under the radical positive. Those are the ones we want to get. For the first problem, we find the bad point. For the second problem, we are going to find the good points. So you say, I want a plus 7 to be positive or equal to 0. What are those? You solve this exactly as if you're solving equations. You subtract 7 from both sides. And you say, I want a to be greater than -7. Again, these are your numbers. These are your inputs from negative infinity to positive infinity. What are the numbers I can pick? Can I pick everything from negative infinity to positive infinity? And the answer is no. You could only pick a's that are bigger So let's find negative 7. So if this is 0, negative 7 would be here. It would be on its left. I want all the numbers that are bigger than negative 7. So all these numbers. Note how I drew the real line for this problem. I put a line, I put a negative infinity on this end, infinity on this end, put 0 in the middle. Look at this number. If it's negative, I put it on the left of 0. If it's positive, I put it on the right. And then I look at this sign. This sign says pick everything bigger than negative 7. How about negative 7 itself? Is that okay to pick? The answer is yes. I put this dot saying negative 7 is a number I could pick as well because of this equal sign. So you put a circle. And here you said x cannot be negative 3. So you put an open circle saying I don't want it. So that's why you put parentheses, because you have an open circle because you don't want negative 3. Here I want negative 7. So when I want to write the interval notation, I start from left to right. Negative 7, comma, infinity. Infinity gets parentheses. In this case, negative 7 gets bracket because negative 7 is a point that is acceptable because minus 7 plus 7 make under the radical 0, and the square root of 0 is 0. For the next problem, we want under the radical to be positive. So I want 5 minus 5x to be greater than or equal to 0. Yes, you do have a denominator here, but the denominator is a constant. So this is not a rational function because you just have a 5 in the denominator. There is no x in the denominator. So we are going to make sure that we want to make sure that this side is greater than or equal to 0. So first, you're going to get rid of this 5. Go to PEMDAS. From bottom to top, say, do I have any number being added to x? Yes. Do you see you have a 5 here? This 5 is being added to negative 5x. So you could rewrite it like this if you want. They're the same thing. So you're adding a 5. Here you're adding a 5. That's why. So if you're adding a 5, you want to subtract 5. So you're adding, you do subtraction. So you subtract 5 from both sides. You get negative 5x is greater than or equal to negative 5. Then you say, do I have a number being multiplied or divided? Yes, you have a number being multiplied. Negative 5 is being multiplied. So for that reason, you're going to divide by negative 5. So you divide both sides by negative 5. Since you have an inequality, when you divide by a negative 5, you have to make sure you flip the sign. So when you divide by a negative number, you flip the sign. This is an inequality. If you subtract, you don't flip the sign. If you add, you don't flip the sign. If you divide by a negative number, or if you multiply by a negative number, you have to flip the sign of the inequality. So right now I divide, these are gone. Negative over negative is positive. 5 divided by itself is 1, so you get x. And negative divided by negative is positive. 5 divided by itself is 1. So all the x's that are less than 1. So as I told you, when you want to find the domain, always draw the picture. It helps. What is x less than 1? These are x's that are less than 1. Can I pick 1 itself? Yes. So always question this point afterwards. First, decide whether you are allowed to pick the numbers to the left or to the right of the number, like in this case, 1. Then decide whether to make it an empty or closed circle. So I can pick all the numbers less than 1 and then close it. And when you want to write your interval notation, you start from the left which is negative infinity, comma, to 1. Infinity and negative infinity get parentheses, and 1 is going to get bracket because I could pick 1. Question number 4 says find the domain. Now look, because we have a rational, because we have a fraction here, we don't want to have 0 in the denominator. And because we have a radical, we don't want to have a negative under the radical. So there are 2 restrictions: no 0 in the denominator and no negative under the radical. So how do you deal with these guys? You say I want 2 minus x to be greater than 0. So you don't put equal to, you say I want it to be greater than 0. If you say equal to, like you used to on the previous one, then you're letting x to be 2, and you don't want to have 0 in the denominator, so you don't put the equal sign. You just want it to be positive. So again, you have to go through PEMDAS. You're adding a 2 because this is a positive 2. So again, this is just like having minus x plus 2. They're the same thing. So you want to subtract a 2. So you subtract a 2 from both sides. When you're subtracting, you don't flip the sign. Then you divide by negative 1. But when you divide by negative, you have to flip the sign. X, negative divided by negative is positive. Negative divided by negative is positive. So you want all the x's that are less than 2. So you go to 0, and this is 2. You want all the numbers less is left. All these numbers. Can you pick 2? No. So you put an open circle. How do you write your interval notation? You start from negative infinity, comma, 2. 2 gets parentheses, and negative infinity gets parentheses. You don't want 2, but you want all these numbers in between. The next problem is subtraction of 2 functions. So you have a function f. This is your function f, which is 7x. You want to subtract function g. This is function g, which is x plus 2. So that's this part. We did f minus g. What is this part? This means these notations have their own rule and grammar and their own vocabulary. And what it's telling you is now substitute negative 4 for x's. That's what it means. It doesn't mean multiply this by negative 4. What this tells you is find f minus g, then substitute negative 4 for x. So then change x's to negative 4. That's what the second part is. First part is f minus g. Second part is substitute negative 4 now. You have 7 times x, so you multiply 7 by negative 4. You get negative 28. You have a minus sign. First, go inside the absolute value, simplify this. So when you simplify this, you have minus 4 plus 2. That's what this is. You have minus 4 plus 2. You have to take care of inside the absolute value first. So what is negative 4 plus 2? You have borrowed $4. You return $2. You have to subtract. So you still owe $2. 4 is bigger than 2. 4 is negative. The answer is negative 2. But this was inside the absolute value. What is absolute value of negative 2? Positive 2. So you get positive 2. Absolute value of negative 2 is positive 2. So now you have negative 28 minus 2, which is minus negative 30. Negative 28, negative 2 is you borrowed and then you borrowed. So you borrowed $30. Next problem says, take G, which is X plus 5 inside the absolute value, then minus, take H is X plus 3. That's this part, the first part. Now we want to do the second part. So the second part is going to be done here. It means substitute -2 for all the x's. So I have x plus 5 minus 1 over x plus 3. So do you see I always put parentheses instead of x, and then I substitute this value for x, -2, -2. So what is absolute value of -2 plus 5? I don't need the parentheses anymore. This means 5 take away 2. 5 take away 2, you have to subtract. One number is negative, one number is positive, just like here. Up here, you have a negative and a positive number, so you subtract. 5 take away 2 is 3, absolute value of 3, and absolute value of 3 is 3. What about this one? You have 1 over, I don't need those parentheses. I could drop them. Again, I have a negative and a positive number, so 3 take away 2 is 1. So I get 1 over 1, this is 1, and 1 over 1 is 1. And 3 take away 1 is 2. So the answer to this one is 2. The next problem says, given the functions, you have 7x, you have to multiply f by g. F by g, this is f, 7x. Since it's a multiplication, I put parentheses. Then g. G is absolute value of x plus 5. So you're multiplying two functions. That's the first part. Now the second part says, go ahead, substitute -4 for x's. So this is 7 times x, it becomes 7 times -4. And then I have absolute value. I could put these parentheses. In this case, I really don't need them. And instead of x, I put -4 plus 5. So you go ahead and change this x and this x to -4. So what is 7 times -4? Is -28. You have -4 plus 5 here. So you have a negative and a positive number. You subtract. 5 take away 4 is 1. What is absolute value of 1 is 1. And 1 times -28 is -28. And that is your answer. The next function says, take 7x, that's your f, divided by g of x, which is x minus 4. So that's what the division is going to look like. It's going to be 7x over absolute value of x minus 4. The next step is substitute -4 for x. So the 7 times -4 on the top, and the bottom is -4 inside the absolute value. Right? So I just change all the x's to -4. First step is this part, which you divide the two functions. Let me just get rid of these now. The second part is substitute -4 for x's. Positive times negative is negative. 7 times 4 is 28. You have a -4 and -4. You're subtracting 4 from -4. So that means you borrowed and you borrowed. So you add the two negative numbers and you get -8. But absolute value of -8 is +8. Negative divided by positive is negative. Can I divide 28 by 8? No. But can I reduce it? Yes, because 4 goes to 28 7 times, 4 goes to 8 2 times. So I get -7 over 2 or -3.5. And that is the answer to this one. Then it says, given the functions f of x is -3x, and you have a g, you have a h. G is absolute value of x minus 5. That's your g. And h is 1 over x minus 2. So this problem has to be simplified a little. You can't leave it like that. You can't answer, or right now, I can leave it like that because it's not asking me to find h over g. It's asking me to find h over g at 5. So it's okay, totally is okay to leave it like that. So h is 1 over x minus 2 divided by g, which is absolute value of x minus 5. It's okay to leave it like that because the next step is we have to evaluate it at 5. So then I'm going to go and substitute 5 for the x's. So I don't need to put parentheses because I just have a +5 and I'm adding and subtracting. So x is 5 and then this x is 5. So on the top I have 1. 5 take away 2 is 3. In the denominator I have 5 take away 5, which is absolute value of 0. Absolute value of 0 is 0. I can't have 0 in the denominator. This is undefined. So the answer to this question, when you are doing the homework, it gives you an icon. One of the answers is undefined, and that's what you pick. Is undefined because you end up with 0 in the denominator. The next question says, find p divided by q and then find the domain. So what is p? That's p. It goes here. Divided by. This is the division. This is p. And what is q? Q square root of 9 minus x. Part B says, find the domain for this function. We already have done this. To find the domain, you want to make sure that the denominator is not 0 and under the radical is non-negative. So to find the domain, we say we want 9 minus x to be greater than 0. We want this to stay positive and not 0. To find them, we subtract 9 from both sides because 9 is being added. Remember, this is minus x plus 9. They're the same thing. So you want to get rid of the 9 first. You subtract 9. 9 minus 9 is 0. You get minus x. Greater than is negative 9. Then you want to get rid of this -1 that is being multiplied by x. Negative next to x means you have a -1. So you have to divide both sides by -1. But when you divide by negative numbers, this sign changes direction. Negative over negative is positive x. Negative over negative is positive. 9 over 1 is 9. We want x's that are less than 9. How do I write it? Always draw your real line so that you understand it. It's asking you, what are the numbers that you could pick for input? Well, it says pick numbers that are less than 9. So this is 0. 9 is on positive, so it's on the right of 0. And it says all the numbers that are less than 9. These guys. When you want to write your interval notation, you put the left-hand side number, comma, the right-hand side number. You have to decide whether to put parentheses or brackets, parentheses for infinity, and in this case, parentheses for 9, because we don't have an equal to. We can't pick 9 because 9 will make the denominator 0. So we put an open circle or parentheses here. Next problem says, find v over s. This is v, the square root of x plus 6, over, this is our s, x minus 3. X to the power 2 minus 36. You can write the answer like that. This is not acceptable because you have to simplify. I want to show you a shortcut to simplify this. The bottom function is a fraction. The top function is not a fraction. So make it a fraction. How do you make something a fraction? Just give it a 1 denominator. This is the same as x plus 6. The bottom is a fraction, so that's good. Go far, far, near, near. Far, far, near, near. Or out, out, in. When you have a complex rational expression, you can simplify it by going far, far, near, near. Or out, out, in. So you get x to the power 2 minus 36. Make sure you put a parentheses because when you say out, out, you're multiplying the out, out. So you have x squared minus 36 times the square root of x plus 6. Since x plus 6 has a radical, you don't need to put parentheses. And if you want to, go for it. But it's not mandatory. But for x squared minus 36, you must put parentheses. In. So 1 times x minus 3. When you're multiplying any number by 1, you get the number. 5 times 1 is 5. 1 times 4 is 4. So this 1 is really not needed. You don't have to have it. And you don't need the parentheses, therefore. If you're doing this on a piece of paper and submitting your work, it's fine if you leave these. But if you're doing Alex and it's a software grading it, you have to get rid of that. So that's what we get. That's what goes here. Your answer is going to be x to the power 2 minus 36 inside the parentheses. X plus 6, since there's a radical for both of them, you don't need the parentheses. And the denominator is x minus 3. This is find the domain. So to find the domain for this problem, you have to find what makes this function undefined. And it's just a little bit involved. So you don't want this part to be negative. You want x plus 6 to stay positive. Or it could be 0. You don't want x minus 3 to turn to 0. So we don't want to have 3 here. Positive 3 minus 3 make that 0. We also have x squared minus 36 for s. We don't want to have 0 for that function. Even though our new function doesn't have this in the denominator anymore, we still don't want to get 0 for this denominator that we started with. So make sure you don't have 0 in the denominator here, you don't have 0 in this denominator, and you don't have negative numbers here. We are going to solve 1 inequality, 2 equations. Sorry, something happened. Let me share my screen with you. I apologize. Oops. I don't know what happened. Okay, so we have to solve an inequality and two equations. Let me clean up this part. We want to solve this equation, x squared minus 36 equal to 0. Remember PEMDAS? You start from the bottom, go up. I look to see if I am adding or subtracting from x. I'm subtracting. I have a negative 36. So I add 36 to both sides. Then I look to see if I'm multiplying or dividing something by x. Do I have anything here? No, I just have a 1. So then I go to the exponent. Do I have an exponent? Yes. How do we get rid of the exponents? You put a radical over both sides. You put a radical over both sides like that to get rid of that 2. But the side that has a number not only gets the radical, but also gets a positive and negative. So square root of x to the power 2 is x, positive, negative 6. These are the bad points. These are bad because they make this function s equal to 0. So 2 bad points here so far. What are the bad points? 6 and negative 6. The final function also has a denominator, x negative 3. We don't want this guy to be 0 either. So how do I find that? I just said x minus 3 equal to 0 and add 3 to both sides. And I get x is positive 3. That's another bad point. 3 is bad, 6 is bad, negative 6 is bad. Remember, you're looking for your input. You're saying, what are the numbers I can pick from here from negative infinity to positive infinity? So far, we found 3 bad points. What else? We also don't want this radical to be negative. So lastly, I'm going to solve that. I just want to make sure a square root of x plus 6 stays positive. So I say x plus 6 could be greater than or equal to 0. That's okay to be 0. Then I subtract 6. I get x is greater than negative 6, but I can't pick negative 6, so I might as well drop that because negative 6 is one of the bad points, and this happened to be negative 6. If this was a negative 5, that would be fine. But since I have negative 6 as one of the bad points, I should get rid of that equal sign. So it's only x's that are bigger than negative 6. So definitely you need to put your real line, put a negative infinity, positive infinity. If 0 is here, then the numbers around it is negative 6 is on the left, positive 6 is on the right, and then you have 3. So it says pick anything bigger than negative 6, greater than. So all these numbers are good for that. But then I realized that, well, I'm not supposed to pick 3. So put a hole here. You're not supposed to pick 6. Put another hole here. You're not supposed to pick negative 6. Put another hole here. So now the domain or the numbers for input are these guys, and these guys. So it broke the interval into 3. You have this interval, you have the middle one, and then you have the last piece. You start from left, negative 6, comma, positive 3. Those are all good to pick. 3 is not good and negative 6 is not good to pick, so put parentheses, union, 3 to positive 6, union, positive 6 to infinity. That is your domain. It says R minus P, so we want to do subtraction. This is R, negative 3x. You have a subtraction sign. This is your P. X to the power 2 plus 5x. Did you see how I put parentheses here? That's super important that you note that, because you have two terms here. If this was not there, then you write minus 3x minus P, which is that. And it's okay not to have parentheses. But when you have two terms, you must put the parentheses, because this negative, if you write it like that, then you're just subtracting x to the power 2, but you have two things to subtract. So you have to put the parentheses, so then you remember to subtract both of them, okay? So that's important that you put the second set of parentheses. Then you have negative 3x. This negative gets distributed, makes x to the power 2 negative, a subtraction, and makes negative positive 5x becomes negative 5x. So now you look like for like terms. You have negative 3x, you borrow 3x's or $3, then you borrow another $5. Negative 3 and negative 5 is adding two negative numbers, gives you negative 8x. Negative x to the power 2 is not like term, doesn't have a like term, so you write minus x to the power 2 minus 8x. They are not like terms to get combined. Then it says find the domain. Domain for negative 3x is everything, because it's a polynomial. Oh. I think I don't know if you're seeing my screen. Yes. So the domain for negative 3x is everything. And the domain for x squared minus 5 plus 5x is everything, because they're both polynomials. R is polynomials, P of x is polynomials, because the exponent of x is positive integer. So the domain for this one is also going to be everything. This is a polynomial. We started with two polynomials, so the domain is everything. Number 13 is composition of two functions. So I have g of x. How do hg of 8. How do I go about these? You take care of g of 8 first. So step 1, find out what is g of 8. And when you're doing g of 8, that means change x to 8. So you have 2 times x, it becomes 2 times 8. 2 times 8 is 16. The square root of 16 is 4, because 16 is 4 times 4. You have 2 4s, it comes out as 1 4. Then you have to do the second step. Step number 2 is you find h of, instead of g of 8, I have 4. So now you want to find h of 4. So this g of 8 itself is 4. So now you go and find h of 4. So go to function h and change x to 4. So you have 4 times 4 plus 8. So you go to function h, g of 8 is 4. So then you go to function h and you evaluate it at 4. And you change that to 4. 4 times x becomes 4 times 4, which is 16. And 16 plus 8 is 24. So the answer is 24. I need to erase a little bit of writings I have done because now my the file is getting so big and it's glitching. It keeps freezing on me. So let me okay, maybe it will be a bit better now. Okay, so we are going to go to the next problem. It says find h of f of 3. Step 1, we're going to take care of f of 3. F of 3 is going to be a number. Then you find h of that number you get. So let's find f at 3. So I'm going to put 3 for x. I get 3 to the power 3 because you change x to 3 and you change this other x to 3. So what is 3 to the power 3? Don't do anything, mental math here. Just write it out so you don't make a mistake and write it as 9. 3 times 3 is 9, and 9 times 3 is 27. 8 times 3 is 24. 27 take away 24 is 3. So you found the number 3. Next is we are going to go out, find, see, f of 3 now has become, this is 3 now, so we want to find h of 3. So step 2 is find h of 3. F of 3 happened to be 3, so now we are going to go to function h and evaluate it at 3. So we are going to change this x to 3. So we get 5 times 3 plus 9. 5 times 3 is 15, and 15 plus 9 is going to be 24. So the answer to this one is 24. Let's go to the next problem. This one says, is the same as before. This is another way of writing find g of f of -2. It's the same thing, only different way of writing it. It's the composition of two functions. They call it graph of -2. It means go to step 1, find f at -2. Whatever number you get, put it here, and then find g of that number. So it's the same as the previous problem, only this is another way of expressing it in math. So what is f of -2? That means go to this function f and put -2 for x. So I get -2 to the power 3. Make a note here. I am putting parentheses when the numbers are negative. When the numbers are not negative, these parentheses are not needed. Minus 5 times -2. So -2 to the power 3 is -2 times -2 times -2. Negative times negative is positive. Positive times negative is negative. 2 times 2 is 4. 4 times 2 is 8. So I get -8. Negative. 5 times -2 is -10. So you could go -5 times -2 is a plus 10 addition. As long as, however, you just pick one method and consistently use that method as long as you know that this turns into addition. Or you can use my method and say, this is -8. I have a subtraction here. Let me find the answer to that. That's a -10. You could put parentheses or just leave it as -10. But then negative and negative turns that into an addition. When you have a negative number and a positive number, you subtract. 10 take away 8 is 2. So the answer is 2 here. Let me get rid of these. I got a 2 here for f of -2. So then f of -2 becomes, f of -2 now is is 2, right? This was f at -2, and f at -2 is 2. So I changed f of -2 to 2. Then now I have to evaluate g at 2. And this 2 is coming from here. So I go to function g. It is 3 times x, so it becomes 3 times 2. 3 times 2 is 6, and I can simplify it. I can't do any better than that. The answer is square root of 6. Let me erase so that the file doesn't get too big. The next thing we want to do is, again, composition of two functions. This time we don't want to evaluate it. We just want to leave it as x. So this one is just a little bit different. We're doing the same thing. So what is this? This means q of n of x. So I don't have to evaluate n at any number because this is not a number here. This is just an x. All is saying that take this n, put it in here for x. That's all it is. This is n. N is green. X minus 3. Put it for x for q. Q is the outer one. N is the inner one. Put the inner function for the outer function. So change that x to n. And n is x minus 3. So that's all I have to do. Change x to x minus 3. Remember, this was an x, and we want to change x to x minus 3. So what is -3 and -10? Because they're like terms, we should combine them. -3 minus 10 is -13. And that is our answer. This is find the domain. When you want to find the domain, you have to go to the starting function, find the domain of the starting function. The domain of the starting function is -infinity to +infinity. Everything, because it's a polynomial. And then go to the final function. How about the final function? What is the domain of the final function? The domain of the final function is what are the bad points? Because we have a x in the denominator, so we have to solve this equation to find the bad point. So we set it equal to 0. We add 13 to both sides. We get x is 13. That's our bad point. So we don't want x to be 13. Again, -infinity to +infinity. Can we pick anything we want here? The answer is no. We cannot pick this guy, but we can pick anything before, anything after. So to write the interval notation, we start from -infinity to 13, put a parenthesis for 13 to exclude it, and then again, parenthesis 13 to exclude it and say I don't want it. And that is your domain. The next problem says, evaluate fog of x. The same thing. It means go to function f, change its x's to g. So I have to go to function f, and put G for X. So go to function f, change its X to G. But what is G? G is the square root of 3 plus X. So I go to function f. This is my function f. I have to change its X to G, and G is the square root of 3 plus X. And then do you see you have a 2 here? Make sure you put the 2 here. So that's what that is. G is the green function. The green function goes and sits where X is. This goes and change X to that. So that's what I did. So I have 4. I have a square root of 3 plus X to the power 2. What happens if you have a square root of 3 plus X to the power 2? That piece, this 2 and that radical cancel each other. You get 3 plus X. Okay? So when you have a square root of 3 to the power 2, this becomes 3. If you have a square root of 5 to the power 2, this becomes 5. If you have a square root of 4 to the power 2, this becomes 4. So again, that piece becomes 3 plus X plus 36. Again, you should simplify this because you can combine like terms. 3 and 36 gives you 39 plus X. Or you could write it as 4 over X plus 39. Either way. Okay, so that's about 39. You could write it like that or like that. What is the domain? For the domain, you always start from inside function, and then you go to the final function. So we start with this guy, and then we also have to look at the final. The starting function is radical, right? We start with a square root of 3 plus X. We want to make sure 3 plus X is greater than or equal to 0, because right now it's not in the denominator. So we want it to be greater than or equal to 0. We subtract 3 because 3 is being added to X. This is the same as X plus 3. They're the same thing. So you want to get rid of the 3, subtract 3. So you get X is greater than or equal to negative 3. That's what you get. That's your domain. You can pick all the numbers. Bigger than negative 3. But here, the denominator has, you have to look at this denominator. This denominator says, is a fraction. You have an X in the bottom. You don't want to have 0 in the denominator. So you say X plus 39 is equal to 0. Let me find the number that makes the denominator equal to 0. You get X is 30, negative 39. That's a bad point. That's a bad point. But that bad point is going to be somewhere here, because negative 39, I should make it open circle, is a bad point to the left of negative 3. So it's not even going to bother us, because to start off, we have to pick numbers bigger than negative 3. At the end, we have a number that is outside of that, so we don't even care about it because it's not in here. If it was in here, we had to exclude it. But since it's outside, we don't worry about it. And our domain is going to be from negative 3 to infinity. Negative 3 is included. Question number 18. We have a law office orders business stationery. The cost is $24.75 per box. and write a function that represents the cost in dollar for X boxes. So if I buy one box, I pay $24.75. If I buy two boxes, I have to pay 2 times 24.75. If I just round this up to 25, if I buy one box, I pay this much. If I buy two boxes, 2 times 25, then I pay 50. So I always pay 25 times X. For one box, it's 25 times 1. For two boxes, it's 25 times 2. That's what this says. But I rounded the number so I wouldn't, say 24.75. So it says let X to be number of boxes. So then the cost is going to be 24.75 X. Again, one box is going to be 1 times 24.75. Two boxes will be 2 times 24.75 and so forth. So that's the cost function. Then it says there is a 5% sales tax on the cost of the merchandise and 9.28 for shipping. Write a function that represents the total cost. TA for $8 spent in merchandise and shipping. So there is a 5% sales tax. So the cost gets multiplied by 5% cost times 5%. And how do I write 5%? You don't leave problems like that. You go 5% is 0.05. Sorry if my computer got, again, I lost, is glitching. So I lost my, you don't see my screen anymore. Bear with me, I have to connect it. Oh, okay. It should come up again. Okay. So you don't leave things with percent sign. 5% means 5.0. You push the decimal point back 1, 2 places. You write it as 0.05. So 5% is 0.05. When you want to find the tax on something or commission on something, you go cost times 0.05. That is the tax plus the cost plus the shipping. And you don't leave it like that because these two are like terms. So technically you have to add them. You have the cost plus the tax on the cost. 1 plus 0.05, they're like terms. You add their coefficients. So you get 1.05. You write this as 1.05C plus 9.28. Then it says, find TOC. So they want you to substitute TOC, T of C of X. That means take this C of X and substitute it here. So you get 1.05 times, instead of C, I am going to put the green C, which is 24.75x plus 9.28. So you can't leave it like that. You need to multiply these two. Let me get my calculator and find out what point is. 1.05 times 24.75. That is, oops, you put it as 25.9875x. You multiply these two coefficients plus 9.28. That's your T of C of x. Then it says find T of C of 6. All you do is you put 6 for x. That 6 gets substituted here. So you go 25.9875 times 6 plus 9.28. So we multiply that by 6 first. You multiply these two first in the calculator, and then you add next 9.28, which is 165.205. So it says the total cost for 6 boxes of stationery is $165. I don't know whether they put it as 21 cents. Yeah, round to the nearest cent. You don't pay 205 cents, you pay 21 cents. If this is 5 or more, then make this 1. If this is 4, 1, 2, 3, 4, then you drop it. So round it to the nearest cents, it becomes 21, and that is the answer. Question number 19. It says find two functions f and g such that h of x is f log of x. So it says what are these two functions I have to mix to get this one? So do you see you have a 6x plus 7? I would call that g. So start with g. G is what's under the radical. G is the function under the radical. So under the radical, you have 6x plus 7. That's your g. So where is it? G is 6x plus 7. That one. And then what is your f? F is the one that has a radical like that. That is your f. F is the outer one. The outer one has just the radical, and it's an x, but then g goes and sits in place of x. So that is going to be this one. So that's the outer one, f, and the inner one is g. The same thing for the next problem. The outer one is what is inside the absolute value. That's your g. G is what's inside the absolute value. And then f is the absolute value. That's your g, and that's your f. So let's look for that. G is 5 minus x to the power 2. And f is absolute value of x. Those are the two functions. And that's the final question.